last class start করছিলাম, so let me explain what this is. So this is the energy levels of an atom. So একদম basic একটা concept, তোমরা একটু শুনো, কিছু লেখা লাগবে না, no tonic cometer, is just বুঝার ব্যাপার. So when you look at an atom, and last class we talked about this, the atom consists of protons and neutrons in the nucleus, so you're aware of that. এখন can you tell me where are the electrons? Just our reminder. Where would you find the electrons? Yeah, around it, right? So there have been different versions of this. যে কোথায় থাকতে পারে atoms চারিদিকে electrons গুলো, and it has been progressing over the years. So first ছিল কি যে এরকম করে গোল হয়ে থাকে. That was the Rutherford planetary model, right? And then Niels Bohr found that there's a problem here. Problemটা কি ছিল? That the electrons can only occupy a certain location. আমরা ওইটা নিয়ে কাজ করব। আচ্ছা, we won't go any further than that. So according to the Bohr's model of the atom, the electrons can only lie around the nucleus at fixed locations. Why fixed location? ওইটা আমাদের দেখতে হবে, okay? Also disclaimer, তোমাদের হচ্ছে syllabus is only dealing with the hydrogen atom. আচ্ছা, অন্য কোনো কিছু নিয়ে ওরকম question দিবে না। Right, so these are called energy levels. Now, for hydrogen, can you tell me how many electrons are there? Just one, right? There's one solitary electron out there. So hydrogen has just one single electron in the first shell of it. Now, what is this electron actually doing? So if you go down to this level, right, and you see and look at the electron, what would you notice this is doing? So yeah, there are many theories out there. The one that's accepted right now is that the electron is like moving around. And the question is, why does the electron need to move around? Do you have any idea about this? Right, exactly. Because if it's stationary, what will happen is the nucleus is positively charged and your electron is negatively charged, right? The attraction electron. But if you want to prevent it from crashing into the nucleus, you have to ensure that it's undergoing what motion? Circular motion, right? That's what we thought. But that's when the problem came along. Problem it means your electron can be anywhere. মানে এখানে কিন্তু কোনো problem নাই. You can keep it here, you can keep it here, you can keep it there. Your electron could literally be anywhere. But we find that the electron is not literally anywhere. There are fixed locations where we find it. So এটা আজকে address করতে হবে, that why are there fixed locations where you find the electron? Why can't you find it everywhere? Okay. Okay, so why is it that the electron only is available at these locations? So listen carefully, a part is too complicated. So according to Niels Bohr, he found that the electron has to be in the form of a wave here, along with the fact that it's also a particle. So you need to satisfy two requirements. You need to first satisfy the fact that it's a particle. And if a particle has to remain in a orbit, it must be going at a certain speed. So we'll do a quick recap of our circular motion. Can you tell me, circular motion what's the formula for centripetal force? Right, Fc equals to mv squared divided by r, right? Can you tell me another equation from this topic for centripetal force? Right, m omega square r. So from this equation that you see here, centripetal force is equal to mv squared by r. What does that tell you? That for a particular location, on a particular radius, you need to have a corresponding what available velocity, which means this electron that you see here, in order to stay here, it must be moving at what speed? A very particular speed, right? If it's a little faster, it'll fly away. If it's a little slower, what will it do? Crash. Remember, I went through this. So it has to be a very particular speed here. This is which property that we are trying to satisfy here? Particle property. But then we realize that electrons can also be what? Waves. And to satisfy wave behavior, you have to understand that a wave, it can only be possible if it forms a what wave? Stationary wave. That's when Niels Bohr did the math, right? And he found out that the electrons can only lie at very particular location around the atom, around the nucleus, very particular location. And those happen to be the exact location where what can form? stationary wave. Acha. So stationary wave to a smaller version is definitely difficult, but I'll try to show you, let's say, 4 stationary wave কিরকম দেখতে আসে. I think I showed an animation last class, remember? ওরা oscillate করে. So stationary wave টা এরকম দেখতে হয় যে তোমার এটা wave and particle at the same time, right? So it goes this way, it goes that way, it goes this way, and এইভাবে continue করতে থাকে, and then you have your that structure forming here. Okay, that's basically your stationary wave structure. So এখানে কয়টা হারমোনিক দেখা যাচ্ছে? 1 2 3 4 5 6, right? আমি 6 তে স্টার্ট করলাম because বাকিগুলো ড্র করা একটু difficult. Can you tell me when will the next stationary wave form? 7 harmonic, right? Now unfortunately, if you increase the length slightly, 7 harmonic fit করবে না, R2 বাড়ালো 7 harmonic fit করবে না. So বাড়াতে when you reach this location, you have the right space for how many harmonics to fit here? 7. That's when the next stationary wave shows up. And then next কখন হবে? 7 এর পরে 8. So 8 এরটার জন্য আবার দেখবা যে এখানে হচ্ছে না, একটু বাড়াচ্ছে, হচ্ছে না. Once you reach that location, you have the 8 harmonic out there. So the way the harmonics work is basically that you have to reach the right location for a watt to form around your nucleus, stationary wave for the electron. And if you remember that at the end of the day, stationary wave is basically what confined between two fixed point energy, right? So it turns out these values, these shells, right, they have values out there, fixed values, যেটা হচ্ছে এনার্জিটাকে represent করে. That's why they eventually are called energy levels, right? Now এটা আমরা ইউজ করবো না এই ডায়াগ্রামটা, because আমাদের ডায়াগ্রামটা হচ্ছে আর too complicated, আর too easy, এর থেকে easy করতে হবে. So what we'll do is we'll take this picture and we'll work with only that much. So তোমাদের syllabus when you draw energy levels and structure, আমরা এই ভার্সনটা draw করি যেখানে we have the nucleus at this location. This is the nucleus, and nucleus এর বাইরে what do we draw? The energy levels. The energy levels are drawn using what line? Dotted lines. And each energy level কি বলে তোমাদেরকে? That the electron will be able to be a stationary wave at these locations out there. Do you follow what I'm trying to say? Now, এখানে a bit of chemistry overlap হবে, but না বুঝলে problem নাই. If you have an electron in an isolated atom of hydrogen, for example, right? Is an isolated atom of hydrogen মধ্যে, you have this electron here. Can you tell me what is the requirement so that this electron can move up the shells? Energy. You need to provide it energy, right? So once you provide energy, it jumps up to the higher shells, and it keeps going up. And at a point, it'll reach this level here, which is the last place it can be before it gets what? Released, right? Once you provide energy higher than this value, what does the electron do? Yeah, it just goes out. And this energy needed to remove the electron from here all the way there and out is called the ionization energy. So there's this thing called ionization energy. If you don't have chemistry, it's completely fine. It's basically how much energy you need to remove what from an atom? Electron. Okay, but from a what atom? Isolated. Okay, because when they're in groups, like bonded, talking about values will change, right? So we only deal with what here? Isolated atoms. Okay, so the amount of energy needed to remove an electron from an isolated atom is called ionization energy. Our syllabus doesn't go that far. We'll be inside here. So কি হয় এখানে একটু বলি. So if you have this electron here, and these are called energy levels. Energy levels এর value গুলো আমি লিখবো, তোমাদেরকে এক্সপ্লেইন করতে হবে ভ্যালু গুলো কেন এরকম দেখতে, যেগুলো লিখবে এখন। এটা -13.1 eV, এটা -10.6 eV. I'm making these numbers up. তোমাদের হচ্ছে এটা দিয়ে দেয় সবসময়, ওকে? -7.1 eV, -6.4 eV, will go to -5 eV, and 0 eV. What are these numbers here? So if you remember, we did a chapter in electric field, and the chapter was called electric potential. Do you remember we drew lines around an atom or around a charge where there were these lines where energy was same? Do you remember what was that known as? Equipotential line, right? So equipotential lines will represent that if you're at this location around the nucleus, the value should remain what? Same potential, right? These values that you see here, these are actually electrical potential energy values. Mane hocche, if I want to take my electron here, if I want to take this electron all the way out to that place, how much energy should I provide to this electron? Exactly, okay? So you get 13.1 eV. So just imagine that these values that you see here, they represent the amount of energy that you need to provide toward the electron from the atom. Completely remove it. Now, let's imagine that the electron is at the furthest possible level out there, where the potential energy is zero. Can you remind me what distance could this be? Infinite, right? But because the definition of electric potential was that at infinite, what was the value? Zero. আর তার নিচে সব ভ্যালুগুলো নেগেটিভ থাকতো. Remember in the gravitational field কেন নেগেটিভ থাকতো? Because you're losing potential energy as you go downwards, right? আচ্ছা. So you have your electron all the way up here. It's almost at the threshold of being released. Okay, release করার জন্য কি energy দিতে হবে? If your electron is at infinite, right? How much energy should you provide to your electron to remove it? Infinite? No. আমি বলি আচ্ছা অল্প তোমরা পারবে it's actually easier. You have this particle here. The closer it is to the, let me first make sure তোমরা এটা বুঝো না এটা কিন্তু negatively charged, okay? And what is your nucleus? Positively charged. So what is the negative charge electron experiencing from the positive charge? Attraction, right? So তোমার এখান থেকে যত দূরে যাওয়া ওটাকে মুভ করতে কি ইজিয়ার হবে না ডিফিকাল্ট হবে? ইজিয়ার হবে, right? Now you have gone to a distance that's infinitely far away, right? That's infinitely far away. Will it be, will you require a lot of energy to remove it or very little amount of energy? Very little. And in theory, if you are at the infinite line, right, how much energy should you provide? Zero. তার জন্য যে ভ্যালুটা 0 eV. So these numbers basically tell you how much energy you should provide toward the electron. Move the electron completely out of the atom. Okay, right? So energy level gulo arpor bujhe nei ekটু দিকে দেখো. So the energy levels are basically the energy that the particles have in order to be removed entirely from your atoms. এটা একটা analogy আছে, analogy তে দেখো বুঝো নাকি. So imagine you have this floor এর নিচে there are different racks মানে হচ্ছে shelves এর rack থাকে না ওরকম rack. আচ্ছা, this is underground. And you have this surface মানে একটা বেসমেন্টের ছাদ যেটা, this is the surface. এখানে আমরা assume করলাম GP is 0. So you have already said that the GP here is 0, right? So if you go evolve উপরের দিকে, you'll gain GP, positive value হবে. If you're beneath the surface where the surface is 0, if you're beneath that, what should the values have to be? Negative, right? So that's why negative. It is just conventional set kora. Now, if I want to tell you how much energy is needed to remove a ball that's at this level and take it all the way up there, right? আমি কেমনে ক্যালকুলেশনটা করব? আমি এই পয়েন্টের কি বের করব? GP, right? And then আমি এইটার কি বের করব from that point to that point, the difference, the amount you need to take to the top. Exactly same way, this is called the ground state. এটা হচ্ছে the highest, most excited state. This is the highest energy level attainable, and এটাকে বলা হয় ground state. Ground state হচ্ছে where the electron would be naturally. Okay, so that's your ground state. We are dealing with what here? Hydrogen. So hydrogen has only one electron, right? So আমি এখন তোমাদেরকে চ্যাপ্টারটা বুঝাই. So chapter যেটা শিখতে হবে আমাদের is that you have your electron here and you want to excite the electron. So excite মানে energy দিবা, it can go up to higher energy level. First thing that you need to understand, if you want to excite an electron, there are many ways out there. You need to know 3 ways. Can you tell me different ways in which you can excite an electron in an isolated atom? Huh? Yeah, you can provide heat, and a heat যদি enough provide করে electronটা বের হয়ে চলে যাবে. This process is called thermal ionic emission. I've said this before as well, okay? What else can you do? Yes, that's very good. You can provide electrical current, and current will, the electrons that are coming through your circuit will bombard with the electrons in your atom, and they can move out as well. It's also electrical ionization. Okay, so that's one other way. And there's one third way that is possible. Friction is actually heat. Huh? Light. Okay, our chapter is dealing with light, so I'm gonna light and take. Yes. Kunta. No, you can do it. ওটা হচ্ছে photoelectric effect, where you want to remove electrons from a metallic surface. If you have isolated atoms, right, you can use light. There's no problem there. So the thing, it's a very good question actually. So let's say I have wood here. and I shine light on it, right? Why isn't it not emitting electrons? Because the wood electrons are bounded by giant covalent structures and everything. When you have an isolated atom, right, the electron can freely interact with your light, which is the same for what? The delocalized electrons of the metal. So they both can do the same thing. But when you have a compound, when you have like water, talking it because the electrons are bounded.
So there's a light skip
when it interacts with
the
isolated atom, it's a photon. Yeah, right. So আমরা যেটা করব is we'll use light to excite the electron. But before I show you how to excite the electron, there are a few rules we need to follow. Number one হচ্ছে, if you want to excite an electron, there's a very strict requirement. Requirementটা হচ্ছে, you can only provide energy, right, that is equal to the need. Otherwise, the emission won't, or the excitation won't take place. মানে হচ্ছে, if I say that this value here, let me clarify it. Let's say this value that you see here is minus 10.1 EV. Can you tell me what's the difference? A দুইটা শেলের difference কত? 3, right? If you provide 3.1, this electron is not interested. If you provide 2.9999, this electron is not interested. This will only go from here to there only if you provide what amount of energy? The exact amount of energy, like to the final decimal place, okay? So therefore, if you want to make sure your electron goes to a higher energy level, you have to make sure you provide the exact amount, okay? So there's no build-up situation here, one-to-one interaction, remember that? Our the misconception থাকে, what if I provide more, like 3.1 দিলাম, প্রবলেমটা কি, তোমরা এখান থেকে এখানে গেল 3.1 নিয়ে, 3 তো ইউজ করে ফেলো, কত বাকি থাকে? 0.1 এনার্জি যেটা থাকবে, এই electron যদি নিয়ে নেয়, it can't stay in the shell anymore because the stationary wave properties will change, so it doesn't even go there to begin with. মানে the problem is কি, if you have excess energy, তে তো কোনো জায়গায় যেতে হবে, কিসে যাবে এখানে? Either in the form of K or in the form of what in this electron wave. Wave energy বাড়ায় দিলে তো কি চেঞ্জ হয়ে যাচ্ছে, or stationary wave property change হয়ে যাচ্ছে, and it doesn't become a what anymore, stationary wave. So the electron will only take in the amount it can to be a stationary wave. মানে আমার হারমোনিক্স মেইনটেইন করতে হবে না, আমার 6 থেকে 7 যেতে যদি 10 joules লাগে, do you get my point? 6 থেকে 7 যেতে যদি 10 joules লাগে, 10.1 দিলে it's not going to be a stationary wave, so it won't take it. No. So it can release the energy in some form, but we'll see that, but not in this case, okay? So now you have your electron that goes from here to there, there, right? So I'm going to teach you a term which you have actually seen before. Maybe now it will make sense. From this bottom state to the top state, right? Can you tell me how many different ways can I go up? 3. From here to there, how many different possibilities? তুমি কি ম্যাথ করতে পারো এটা? No, just wondering, do you know the math? 7? 1, 2, 3, 4, 5 factorial. 6 নিছো? The gaps গুলো count করবা। 120. So do you know what that is? Permutation, different permutations. আচ্ছা, ব্যাপার না, একটু এদিকে দেখো, তোমরা চাইলে কাউন্টিং স্টার্ট করতে পারো, বাট ইট উইল টেক অ্যান awfully long time, তার জন্য আমি আগে থেকে বলে দিয়েছিলাম চেষ্টা করো না। So do you see these lines that I'm drawing? What do they represent? The different paths that your what can take, electron can take, right? So একটা electron ground state থেকে উপরে যাওয়ার সময়, how many different pathways can it follow? Yeah, so এখানে 1, 2, 3, 4, 5 দেখা যাচ্ছে, but that's not it, right? Because what if the electron went here, and from there to there it did a jump, and then from there to there it did a jump, and then it went from here to there? Isn't that another type of combination out there? Or what if it went from here to there, and from there to there? That's another type of combination. The point I'm trying to make here is that there are a lot of different what possible here combination, right? Our প্রত্যেকটা gap into unique value. Doesn't it mean that the electron will use different types of energy to make the jump? So আমার যদি এখানে 4টা শেল থাকে, the energy requirement কি 4টা হবে নাকি 4টা বেশি হবে? That's my eventual question. That you have 4 shells, your electron is here. To go to the top, are there only 4 different ways, or are there many more different ways? Many more different ways. আচ্ছা, so এই যেগুলা উপরে যাচ্ছে. Now the term that I thought you might be able to relate to is that these are called transition states. So transition station কোথায়? Right, there's a whole group in your periodic table dedicated for it. It's called the transition metals. Transition metals key. So do you know what are the properties of transition metals? Yeah, so আমরা physics part থেকে we'll just focus on one. They're very colorful. The thing is that when they form compounds, right? So most of the color pigments that you know, like every color that you see around you, is actually made from transition, right? So like blue, green, yellow, orange paint you use kora hoy, they come from chromium, nickel, zinc, all those elements out there, right? So yeah, this is your electron movement. Electron has many different ways to move to the top, and there are different combinations out there, and it will only move up if it has what amount of energy available, the right amount of energy available. Okay, so this is the background I wanted you to know before I can start the syllabus topic. So I have some questions for you, okay? See if you can answer. Question number one hoche, can an electron occupy any shell here? Yes, okay? But there's a restriction. If you go beyond this shell, the last shell, what happens to you? Yeah, the electron is gone. So there's this very famous question from particle physics. How many shells are there in hydrogen? Multiple. How many? I want a number. How many shells are there in hydrogen? It's a very straightforward question. 1. 60? Not 60,001? Maybe. Infinite. Okay. So how many of you think that hydrogen has one shell? Hydrogen, the element, the most fundamental element out there, the universal building block, how many shells does it have? 1, right? Okay, so the correct answer is actually infinite. And the reason is, so that's not wrong. That's the number of occupied shell. How many shell can hydrogen's electron occupy? How many is that? 1. But if you want to see the total number of shells out there, hydrogen is a shell, and not just hydrogen, for any element, what's the number of shells out there? Infinite. Problem ki hoy, as you try to get to the infinite shell, majkhane ekta point what happens to you? Yeah, you get ionized. You just get, detached from the nucleus, and you have no more attraction to the nucleus. So therefore, you're an isolated electron. So it's like you're trying to climb the top of a building, right? But you jump out of a floor. So how do you even get to the top? Not a good analogy, but I don't have any other. The point I'm trying to say is that yes, the building has 100 floors out there, but you decide to take the exit at the 20th floor, right? So it doesn't really matter how many floors are up there, right? You're already out of it. So same goes with the electron, right? So the electron at one point will get liberated, and as it gets liberated, ekhane aru shell thake. Stationary wave number 1 million. ওটাও তো একটা শেলের shape থাকবে, right? ওটাতে reach করা possible হবে না because the nucleus doesn't have enough attraction to hold onto the electron by the time it reaches that shell. So eventually the number of shells are infinite. The number of occupiable shells are limited though. Exact point for what happens, they're gone, right? So yeah, that is your thing here. One more thing before I explain our chapter requirement. The electron requires energy to be excited, right? These energy values are what? Can you give me a word to describe the energy values? Are they continuous or are they opposite of continuous key? Discrete. Discrete meaning the fixed values, are continuous meaning any value. Do you think the shell values for electron in an atom is a continuous value or is it a discrete value? Discrete. Continuous. Continuous মানে বুঝছো? Continuous মানে হচ্ছে আমার hydrogen electron can be anywhere. Is it true? No, right? Where can it be? Only at certain places. So what would you call that kind of a behavior? Discrete, discontinuous, separated, right? So it's a very important factor. Prior to this, আমরা ভাবতাম electron could be anywhere. But then we found electrons can only be found at fixed levels. And that's where the term came from, energy levels. Is there fixed values out there? So ওরা জিজ্ঞেস করে for 1 or 2 marks, describe the shells or energy levels of atom. The answer would be they occupy discrete energy levels. Also, before I move on, these values are discrete, and more importantly in your syllabus, they're also what? Unique. Unique to what? every element and hydrogen. So তোমার কোনো দুইটা element পাবা না যেখানে এই energy levels গুলো কি same. It is just mathematically impossible. মানে আমার হাইড্রোজেনের যে shell values গুলো, you'll never find them in any other element in the universe. Full stop. There's no exception to it. Exactly, right? They'll never overlap, they'll never match. Now, do you know why it's like that? Why is it that they all have unique values out there? It's a simple explanation. These energy values that you have, they depend on the what number? Proton number. And proton number is what for every element? Unique. That's if proton number is unique, this is also unique. So there is no way you'll have two elements that have overlapping shell values, energy values. Okay? It has to be correction, right? To keep you guys interested. Right, so এখন হচ্ছে টপিকটা স্টার্ট করবো. So it's some background that I wanted to provide you. Now, why do we have this here? Out of nowhere, like a random topic or provide for something about light emission, right? So to দেখো খুবই helpful একটা topic. So if you go into any branch of engineering, especially bio-related, this is going to be like a must. Okay. Right, সবাই স্ক্রিনে এই যে কথা না right, so what are we going to do with this information? So এখন যেটা করব is I'm going to teach you on the chapter requirement. খুব important. Listen carefully. একবার বুঝলে we can be done with this topic by this week. So you have this atom of hydrogen. So I'll write it down here, H plus. This is a nucleus. What does the nucleus of hydrogen have? One proton. Even if it's an isotope of hydrogen, it wouldn't make a difference, because even if it's a hydrogen isotope, the nucleus is still what charge? +1. Okay, so sometimes you might be wondering, what if it's a different isotope? Doesn't matter. Okay, right. So jeta korbo ekhon ei je what I'm going to do right now is I'll go basic. I'll provide heat. So I'm providing heat here, and heat provide korle there's a advantage. What happens is, as you keep providing heat, your electron gains energy, right? Energy gain korte thake. At the point it gains exact energy that it needs for what? Moving up, right? So electron কি করবে এরকম করে উপরে মুভ করবে, আবার হিট দিয়ে যাচ্ছে উপরে মুভ করবে, উপরে মুভ করবে. It keeps moving up like that. Okay, so the electrons can transit if you provide heat. Do you follow? মানে আমি provide করতেছি heat, the electron can transit. So let's look at an example here. You have this atom that we have, hydrogen. These are the energy levels out there. For simplicity purpose, আমি খালি চারটা draw করব. আচ্ছা, there can be more, but we'll just deal with 4 of them. You have your electron that's at this level right now. তুমি এটাকে energy provide করলা, এটা এনার্জিটাকে নিয়ে কি করলো, it moved up. It went from here to there, and then there, and then there. But you haven't provided enough that it becomes what? Emitted. Okay, so electron টা এখন এই জায়গাটায়. Now let's say there are other atoms nearby যেগুলা সব excited হচ্ছে, একটা না, like multiple of them. Okay, you're exciting all of them. এই ইলেকট্রনটাও উপরে চলে গেল. So right now এই যে ডায়াগ্রামটা দেখতেছো, there's a name for this. This is called the excited state. Excited state মানে কি? The electrons are not in their natural level. Where are they? At higher energy level. This can only happen if you provide what to them? Energy, right? But here's the catch. Listen carefully. They can't stay there forever. If you want them to stay there forever, you need to provide energy for what? Forever, right? But ওটা কেউ করে না. So at a point you stop providing energy, and these electrons will do something very interesting. They'll fall back to their ground state. Ground state where they are normally found, right? But you gave them energy though. What would they do with that energy?
Light
or heat? Which one? Acha, so it turns out exclusively electrons, when they transit back down to a lower level, they will only give out the energy out in the form of light. Ar kichu na, no heat, no sound, no nothing, just light. And they will do this randomly. I'll tell you what I mean by random. Sometimes they'll jump from the top shell and fall back directly to the down shell. Sometimes they'll take a path, or ekhane ashbe age, ekটু থামবে, তারপর আবার এখানে যাবে, আর একটু থামবে, and then eventually will decide to go back to the bottom. Sometimes they can do something else. For example, they'll go from here to where? There, and then they'll do that. So it turns out when an electron goes down to its ground state, it can emit light in many different combinations out there. Now the question is, light jeta ber hobe, What color is it? What frequency is it? Depends on the phone. Nah, bolo. But I'm not the heat provide kursi. Right. Right, exactly. So remember there was an energy value here, 0 EV. And remember this was minus 13.1 EV. So when the electron falls back from this level to that level, doesn't it give out that 13.1 EV? That 13.1 EV, ke jodi ami hocche eta bad dei, that's how much? 1.6 into 10 to the power minus 19. I can find out the light given under a very important pretext that the light that's given out from this particular electron is in the form of what? A photon, a particle. If it's not a particle, then আমরা এই math করতে পারতাম না. And this is the reason why this topic has this part included in your syllabus. Light behaves as what when emitted by an electron undergoing transition? Particle. It was something that we previously thought was the other way around. We thought that light came out in the form of what? Waves, right? But turns out light যখন transition হয়, they come out in the form of what? Photons. And if they come out in the form of photons, what formula applies for them? E equals to hf, right? So 6.63 into 10 to the power minus 34 times f যদি করি, আমি frequency of light পেয়ে যাবো. And that's where we found that every single transition here produces what? Light of what frequency? Unique frequency, because প্রত্যেকটা গ্যাপের ভ্যালু কি সেম নাকি unique for every element? Right. So you'll find that every time you have transition taking place in hydrogen, the colors that hydrogen release are unique to hydrogen, and no other element will ever release those colors. Impossible, right? And this then became a very handy tool for physicists to find out what element is out there. So prior to this, তোমরা যখন কোনো element বের করতে যেতা, you had to do chemical tests, which are very tedious, unreliable, অনেক type like requirement থাকে. Now it's very easy. What you do, you take a sample, you put it in this device, right? Or device ভিতরে দেওয়ার পরে you heat it up. As you heat it up, what does the like material start to do? It glows. And when it glows, it gives out different color. But color গুলো কেমনে আসে? Mix হয়ে আসে. So to separate the color, we use a device that are thankfully তোমাদেরকে এসে শিখাইছিল. It's a device with thousands and millions of lines in it. What was it? Oscilloscope. Oh my goodness, honey. Oscilloscope. It's like top 10 worst answers some of the entry Nisa. Huh? Oh, right. Diffraction grating. Yeah, that's yeah. So right, diffraction grating কি ছিল মনে আছে তোমাদের? You had light that entered from one side, a light that had what? Many colors, what in it? Combined in it. As all these colors went inside, from the other side, তোমার যে স্ক্রিনটা থাকে, ওই স্ক্রিনের মধ্যে কালারগুলো কি হয়ে যেত? Separated হয়ে যেত. And that's when we can figure out, wait a second, I get red, purple, green, orange, blue of these exact frequencies. That means it must be what? Hydrogen. And if you take hydrogen of any place and you do this experiment, right? What colors will you get? Exactly the same color. It is basically a fingerprint for an element. So if you go to, let's say, distant galaxies and you find this random element out there and you're curious what this element is, কি করবা? Just heat it slightly. As it heats up, it'll start to glow. Look at the color it gives you, and that color will reveal to you what element it is, because no two elements in the universe can produce what color? Same color, right? And we partially use this in O levels with flame test. So chemistry, the flame test data is actually using this idea, but flame test problem কি? Typical elements won't reveal their colors. Only certain metals do. The flame test was very commonly used for what? Metals, but not all metals can do, because I don't know if you remember, sodium or flame test color ki chilo? Orange yellow, right? What is the flame test color for calcium? Red orange, right? What's the flame test color for rubidium? Red. Chromium? Red. Acha. So point I'm trying to make is they're all red. And if you look at them, right, flame test shamay, I've seen students look at the normal flame and they think they're seeing sodium. It's just flame color. They say orange yellow. They didn't even put the salt properly, right? So the problem is that these are very deceiving. the colors in flame test, right? Unless it's like lilac from potassium, which was not a mistake, right? Or barium or apple green, which is not a mistake. Oh, because green হচ্ছে too dark. Oh, এটা একটু light color হয়. It's pale green. The pale green তো একটু different. I don't know. It's neon green. No, it's actually apple green. সবুজ apple গুলো পাওয়া যায় না একদম same color. মানে there's no other better color for it. Golden apple. Oh, green গুলো? No, they're called green apple. Golden apple. There's some colorblind name there. It is green color. What are you talking about? Or even a branded name. Yeah, I think it's a brand name or something. It's a green apple. It's a universally called. ওই একটা স্টিকার থাকে উপরে গোল্ডেন অ্যাপল লাগে না? ও আচ্ছা আচ্ছা বাংলাদেশে ও তাহলে ইউ ক্যান ল্যান্ড ও গ্রিন লিখতে গেছিল গোল্ড লেগে Right. The point is, flame test is not reliable, but this is reliable because again, we have wavelengths that tell us what the colors are, and they're unique to every element, right? So you can take a spectrum pi, and the spectrum is called the emission spectrum. So I'll show you pictures of it to get a better idea of it.
So why do we get the same number when we go any group
You use the right term. What do? You burn it. That's a chemical reaction. It's oxidation.
Let's say when we do a traces, or let's say one group one.
Yeah.
You always say why.
Group one? No. Q. No, all white color. No, white color আসছে like heavy elements and compounds because there's so many transitions happening. They start emitting what colors? All the colors, 7 colors. So what does it turn out to be? So a very good example of this is magnesium. Magnesium যখন ribbon burn করা হয় একটা bright white color আসে. But magnesium white color কেন দিচ্ছে? Because magnesium যখন transition হয়, if you look at the colors it releases, it's like all colors of the spectrum. So when they eventually add up together, what do you get? White. এই টিউবলাইট যেগুলা এখন তো ইউজ করি না আমরা, বাট টিউবলাইটের ভিতরে কিন্তু আগে একটা এলিমেন্ট ইগনাইট করতো। ডু ইউ নো হুইচ এলিমেন্ট? ফসফরাস। সো টিউবলাইট আগের গুলো এখন পাওয়া যায় না। ইফ ইউ ব্রেক টিউবলাইটস রাইট, দেখবা সাদা একটা পাউডার বের হতো। ওই ফসফরাসকে যখন ইলেকট্রিসিটি পাস করা হতো, the phosphorus used to glow, and the color you used to see is actually the water phosphorus, the emission spectrum of phosphorus. And phosphorus এর মধ্যে এত শেলস থাকে that এত ট্রানজিশন হয়, what color is emitted? Almost all of them. That's why you end up seeing a white color. But I don't know if you know this, tubelated color কিন্তু হচ্ছে blue color. It's our human eye that does the trick and makes it appear neutral. It's actually blue. So অনেক সময় ক্যামেরাতে ছবি তুললে you'll find that যে বাসার ভিতরে টিউবলাইটের মধ্যে ছবিগুলো সব ব্লু হয়ে যায়। And the reason behind that is it's actually a blue color lamp. ওই যখন কালার্স গুলো বের হচ্ছে না 7 কালার্স এর মধ্যে, which colors have more intensity? The blue ones. আবার ওটা এখন আমরা ম্যানিপুলেট করি, যেমন you can now buy lamps that have like cool warm tones থাকে। Cool tones মানে হচ্ছে they remove which colors from it? The orange and the yellow. So what becomes dominant there? The blue. আর warm এর মধ্যে they remove the blue, so it becomes what? Yellow. ওই যে ফোনে থাকে না night mode that turns yellow, তো yellowটা কেমনে করে? What do they turn off from the screen? The blue light, because the blue light is bad for you, right? So yeah, the thing is that it appears white, but it's actually a combination of 7 colors in different ratios. Okay, so let me show you emission spectrum of something. The human brain has evolved to understand blue means do not sleep, and that's because when you see the sky, it's blue, right? So the brain gets a signal that it's daytime. So when you look at a blue screen, your brain yeah, so there's a circadian rhythm of মনে করে you're still in daylight, তার জন্য তোমার ওই sleep mechanism চলে যায়। The white light from the sun comes in and it disperses. The most longer wavelengths go down. So when you're at the ground level, you get orange and yellow. So that's why sun looks yellow. But as you go higher, it gets spread up and the shorter wavelength is blue. So you see the blue at the top. Yes, a lot of people have blue color room walls, right? It's just messed up their sleep cycle forever. You're supposed to have them ওই বাংলাদেশে একটা খুব beige color use করে, that's the best. মনে হয় যে একদম ময়লা হয়ে গেছে। No, that's the good color because that's ওই উপরে yellow কালারটা। হ্যাঁ, ওইটা দিলে দেখবে সবাই সারাক্ষণ ঘুমাচ্ছে, মানে they're always thinking it's sleep time. হ্যাঁ, that's actually a very good, it's a very warm color for you to feel relaxed. কোথায়? The which green color? Oh, so no one can explain. Even they can't explain why they use it. It's a boy cover color. Hey, look at this. These are the colors that hydrogen emit. It's something important. So, hydrogen emission spectrum. So when you excite hydrogen, there are 4 colors that come from it. Wavelength 656, 486, 434, 410. There is absolutely no way any other element in the universe will produce these colors. And this is a very important fact in astrophysics. So, when we look at stars and we're wondering what are stars made up of, we have never been there, right? But we know clearly what they're made up of. How do we figure that out? You look at the colors emitted from the stars, and these are the colors produced by hydrogen, helium, and oxygen. So if you ever see the last colors, nature color from any planet, you know what's in that planet. Oxygen. So the Kepler belt has a lot of planets that are very similar to the Earth, and they say that there's oxygen and water and stuff in it. How do they know? Because we barely know what's in Mars, right? So we'll see the light that comes from that planet, and we investigate the colors available, and the colors match exactly the color of what? Oxygen and hydrogen. And it means that oxygen and hydrogen, they're most likely to fuse together and probably form what at the end? Water. হ্যাঁ, তখন red shift হয়। হ্যাঁ, so red shift এর interesting part, good that you brought it up. Hydrogen এর red shift you'll still see what colors? এই 4টা কালারই। খালি কি নোটিস করবা, ভ্যালুস গুলো একটু শিফট। So you'll find that 656 এর জায়গায় 656.4. So এই 656.4 আবার কোনো এলিমেন্টে নাই। তার মানে it must have been what? Hydrogen, but it got what though? Shifted. And there's a name for that. What is it called? The redshift, right? So redshift we figure out, wait a second, hydrogen did shift, but it shifted. Doppler effect. From there, we eventually found that the galaxies are all moving away from us. The expansion of the universe. Colors are very close together. Which has 650 as well. That's actually a very valid point, but it can't happen for all of them. The iron যদি check করো, iron the number of lines you have is over 21 of them. 21টা overlap করবে একটা হতে পারে. So we don't rely on only one of them, we go for all of them. There's a so if you look at these, এখানে neon আছে, do you see neon এর কতগুলো কালারস আছে? So neon হচ্ছে একটা overlap করতেই পারে, but সবগুলো করার কথা না. So light only shows this particular nature when interacting in metals and when electrons transition downwards. Yes, correct. That's the correct way of putting it. So it shows this particle nature when it interacts with the delocalized electrons of metals, and also when electrons, when they transit from a higher level to a lower level. Right. So there's a name for this thing. This is called the emission spectrum. Okay. So emission spectrum you take a gas and you excite it, ওই গ্যাসটা থেকে color বের হবে, a color unique to that gas, and this is referred as the emission spectrum. Hey, look at this. A atom touch excited, so it's releasing its energy, and there a second, is it? So this is called a line spectrum. So do you see the colors it's emitting? It's sometimes emitting blue, sometimes emitting green. কিসের উপর ডিপেন্ড করে এটা, যে ব্লু এমিট করবে না গ্রিন এমিট করবে? Yeah, energy gap এর উপরে। আর গ্যাপ গুলো সব ইউনিক, তার জন্য they'll never overlap with any other element out there. Also, whether it will be blue or green is actually random. মানে একটা তুমি যদি হাইড্রোজেনকে এক্সাইট করো, ব্লু হতে পারে, অনেক একটা গ্রিন আসতে পারে, একটু ব্লু আসতে পারে, দেখবে তার জন্য লাইটটা ফ্লিকার করে। ওকে, কোন গ্যাপটা? Oh, so your electron is at a higher energy level. Now it needs to go down to its lower energy level, the ground state. It has excess energy in it. What does it need to do? Get rid of it. So when electrons transit from higher level to lower level, they decide to get rid of it only by using what? Light, and not only light, a what of light? A photon of light. Okay, and that's why E equals to HF comes into play. Always a photon. But now if it goes and interacts with a normal metal, it will turn itself into a wave. But the value for the color depends on the particle property. Right. And then these both have something in common. What is it? It's the electron. So electrons and light will always interact in the particle nature of it, not the wave nature. It'll become a wave. So the thing is, it'll turn out to be a wave in the beginning. Now, how do you decide whether it's a wave or a particle? It's the target, right? But the amount of energy it comes up with, that depends on the E equals HF formula. So it means that you still have to consider it to be a what? Particle. So for your math, you have to always take it as a particle. And this, by the way, is the origin of light in the universe. I don't know if you know this. Any light and every light that you see ever, right, is due to what transited within the shells? Electrons. So, the first ever light that came in the universe came because an electron went from a higher energy level to a lower energy level, and it didn't know what to do with its excess energy. So what did it release in the process? Light. And that's the origin of any light. Whatever light you see right now, in its core, there's an electron. There are atoms, there are the electrons below, niche যাচ্ছে, and that's how they're releasing the light out there.
Sir, what about reflection?
The reflection is not a light source. It's just light given back to you, right? So if you go back to the source, it's still an electron transition.
What happens
During reflection? Nothing. It's just the wave particle bounce off the surface. The surface is too rigid. It doesn't allow the energy to move in, so it just bounces off. No, just the whole structure, like the crystalline structure or whatever. No, so that's why is the table, let's say, not reflective? It is very reflective. It's actually more reflective than a mirror. But the reason why the table doesn't look like a mirror is because, yeah, it's not smooth, because there's so many random crevices out there. The light enters and gets stuck inside. But the mirror surface is very reflective because what is it? Very smooth. So everything just bounces off. Okay. Sorry? No. It was a proton. Not even a proton, just a proton, not a hydrogen atom. So the universe at the beginning only had protons in it, no electrons. And then fusion took place, and fusion was what produced the electrons. Neutrons, fusion. So when hydrogen and hydrogen fuse together, on the next chapter program, right? Hydrogen fuse together to form something called deuterium. Or deuterium is when you no, because protons can turn themselves into energy. No, the mass is the word you're looking for. Okay, the mass of the universe in terms of pure mass is still the same, but now it's not in the form of mass anymore. What has it converted to? A bit of energy as well. That is right. So 3 things in the universe is constant: mass, energy. What else? No, mass, energy to both of us. Our duta, duta paragata, we basic universal truth. No, momentum. Okay, the universe relies on conservation of momentum. So momentum is always conserved. And the third one is charge. The net charge is the same in the universe. Yes.
So at the beginning, there was just a single block of mass, energy, and charge, and
yeah. And to conserve momentum, the particles moved off in one direction, every direction, right? Sorry? Baseline. Yeah. No, so quarks can exist on their own. You can't have like a separate quark moving around. So the quarks combine to form the protons, and that's where the most first stable particle is. Ionic particle exists for though. Like antiparticle was also there. Those disappeared. We don't know why.
Which one first proton? What was there?
It's called the omelette. Omelette. The egg omelette. So it's basically that literally the omelette of everything in the universe. So it's like mixed and everything. It's plasma. Yes, you could say everything was just chaotic. Now it's ordered. Okay, so next class I will do the math and it is chapter 2. Just emission spectrum main part. So next class I will wrap this up.
Recording